I'm an econometrician, so that means that I study data, how to use data in economic decisions, how to analyze data, and in particular, I focus on prediction forecasting. So the topic of my talk today, I borrowed this name from Alexis de Tocqueville. So normally you heard about maybe the tyranny of the majority in political science. So here I will talk about the tyranny of the majority in an entirely different context, which is about prediction, and in particular, predicting individual behavior. So this sounds like a negative message, but then I will also talk about how to avoid it. So this talk is based on research that I'm conducting with my colleague Silvia Salpietro, UCL, and Simon Lee at Columbia. Okay, so what is prediction about? So in economics, in business, we make decisions based on predicting individual behavior. So this is very important. So we're trying to forecast, to predict how individuals will behave in the future. So some examples of this for businesses will be try to understand the future spending of existing clients to make budget decisions. As an employer, you will make promotion decisions based on trying to predict the future output of your employees. Or you can think about it in a policy context. An example would be school districts trying to predict future test scores of students in particular schools for funding or college admission decisions. So we focus on doing predictions with particular type of data. So this will be a type of big data. You heard about big data, everyone is talking about it. There are master's programs, there are 5, I think, at UCL starting new this year. So we have this great availability. It's frankly a revolution in economics and in business that we have all of these access to this big data. In particular, for prediction, there's a type of data that is very useful that I will focus on today, which is called a micropanel. So a micropanel is a data set that has 2 dimensions of information. So there's a dimension across individuals. So we observe many individuals. And for each individual, we observe their behavior in the past over a period of time. So we have many individuals that we observe over time. So micropanel may look like this. So each color dot is a different individual, and we measure these individuals over maybe a period of time. This could be years, or it could be months, it could be weeks. So the richer, the better, in a sense. How do we use these micropanels for prediction? So there are existing methods. So I will boil them down to 2 very simple tensions, which are essentially which one of the 2 dimensions are you using the most. Okay, so by far the most common approach is to use the cross-sectional dimension in the panel. So the idea is that we're pooling similar individuals together. So a very simple example of this would be just to take the average, the mean. A less common approach, although there is information in the panel, is by leveraging only the past behavior of each individual. And then there's some more sophisticated methods, which I will call generally Bayesian shrinkage, which is some sort of an intermediate approach. So I will not focus on Bayesian shrinkage to keep this presentation very simple. So you don't need any background. There will be no formulas here. So I will focus on these 2 competing approaches, which is the pooling similar individuals together or using only your own past to predict how you will behave in the future. So there are some great opportunities in these big data in the micropanels, but there are also some limits. So the promise is that there is a lot of information which we can exploit to make better decisions. But there are some important limits, particularly in this type of economic or business data, which is we observe a lot of individuals, but we often don't know that much about them. In a sense, we don't really observe anything beyond a few characteristics, particularly now with the emphasis on privacy. You might move towards knowing less and less about the observable characteristics of individuals that you want to analyze. So for example, about your clients, you may know their age or their gender, where they live. About your employees, you may know a bit more, perhaps their qualifications, their CV. And about students, you may also know their family background. which you think may be an important determinant of their behavior. And in terms of how much history of behavior you know, often you have only a few time periods where you can observe people over time because people drop out of the panel often. It's hard to really collect a lot of measurements for the same individual. So this implies that there are trade-offs, pros and cons, in using each one of the two dimensions in the panel. So either the past behavior or the behavior of other people that are similar to you in some sense. So let's talk about the pros and cons. So using your own individual past behavior. This is very important and it has very important information about your unobservable characteristics. So these are things that we cannot unfortunately see about an individual. We cannot see in terms of a client what the preferences are, what their taste is. Are these big spenders? Are you thrifty? For an employee, we don't observe their productivity, their skill beyond some proxies measurement of them. And for students, we would like to go beyond just their family background and get to their underlying ability, their skill. However, past behavior, particularly when measured over a very short period of time, is very noisy. Because if you think about even a high spending client may have a bad year, productive employee may get ill, a good student may just have a bad day and fail a test. So really leveraging so much of particular behavior, how you behaved last year, there's potentially a lot of noise that you're introducing, and this will be a bad predictor. On the other hand, pooling, which is the reason why pooling is by far the most popular approach here, is that pooling you with other people, particularly when you have a lot of other people, is a fantastic way to reduce the noise. You probably heard of the law of large numbers. This is a very powerful theorem and a very powerful law that applies in nature everywhere, which is when we take averages, we are reducing the noise. So the average, particularly when we have a lot of people, is a fantastic way to reduce the noise. However, averages only work when you're averaging people that are very similar to each other, which is not the case in practice, particularly when you have a lot of individuals. So pooling fundamentally hides all of these unobservable differences among people that we think drive behavior. So what you see about me is that I am a female Italian professor living in London in my 40s, but I don't necessarily behave like every other person who fits the same observable characteristics. Okay, so there are pros and cons. So the bottom line is that existing methods for prediction typically end up pooling in some way individuals, putting individuals together based on some similarities which are observable. So this could be a good way, and it's a very powerful way to, if you think, borrow strength from the majority. But in this talk, I would caution against this pooling turning into a tyranny of the majority in this very specific sense for prediction, which is that hiding potentially important differences in unobservable things we don't see about people that are, however, fundamental in driving how they behave in the future. So what do we do about that? And first of all, why do we even care? What is wrong with the pooling? Well, what we worry about is that this can lead to bad decisions. The most benign version of this would be for a business, it will cause a loss of revenue in the sense that there is information in your data, even data that you have collected over time, that you're not really exploiting fully. So there's something in the data that could actually lead to better decisions in terms of revenue or any business decision. But in a more subtle way, this could also lead to some unfair decisions in a sense of keeping people victims of their circumstances and maintaining inequalities, injustices. So think about the situation of a school district where you are averaging students in a particular school. So you may end up penalizing very good students if they, for socioeconomic reasons, are part of a mediocre school, of a low-performing school, while at the same time you're lifting bad, fundamentally bad students who, by virtue of their circumstances, were able to pay the tuition for a good school. So you are creating and maintaining inequality in this way by bringing people towards the mean. So we try to do something about it. So what we do in our research is to come up with a new prediction method, still based on the same data that you already have. And so we're asking the question of, can we move beyond this tyranny of the majority in pooling everybody by at the same time better exploiting what we already have as information in the panel? So what we're proposing here is a new method, is a data-driven method. I will explain in a very simple example. And this method essentially decides in a group of people who to pool and who not to pool. Okay, so this is a method that at the end will give better predictions than the two competing alternatives now, which is the idea that you will pool everybody or that you use the past behavior for everybody. So I will not have any formulas, as I said, but in an econometric jargon, what we're doing here essentially is individual model selection or a form of model-based clustering or classification. So it looks much more difficult in the paper that will be ready, and if you're interested, you can try it in a month or so on my webpage. So let's talk about a very simple example. Suppose you're down to a group of people that to you look the same. Perhaps you have pooled all of your clients of the same age, gender, location, and to you, they look indistinguishable. Okay, so you have a panel. So suppose we have a few years. So we are in the year 2, and we want to predict the future behavior of these few clients. Importantly, we need to know the behavior of these clients also in the past, so at least one period. So we have the following representation. So let's think about a very simple example. So we have these 4 clients, 4 students, 4 employees, A, B, C, D, of different colors, and we measure their behavior in year 1, their behavior in year 2, and there's some truth that we will try to predict in the future. So we are in year 2. And you see that there's also this black dot pool. So this will be simply the mean. So we can simply take the mean of their spending, of their test scores, of their quantitative measurement of their performance. Okay, so what does our method do? So our method decides which one of these 4 individuals to pool and which one not to pool, based on what happened in the past. So this is the most important slide that boils down the method in a nutshell. So for each person at a time, we are in year 2, we see which of the predictors in year 1 would have been a better predictor for what actually happened in year 2. Better predictor means closer to the truth. So we measure what happens in year 2. We could go back in year 1 and see, would pooling that person in year 1 have resulted in a better predictor for year 2, or would using that behavior of that person in year 1 be a better predictor? So if pooling that person would have been a better predictor, then this means that it's an individual who benefits from pooling. If on the other hand, for one person, their own behavior in year 1 would have been a better predictor of what happened today, this person does not benefit from pooling. And we do this for each of your individuals in the sample. Let's visually represent it, perhaps it will be clear. So we start with the individual A in year 1. We know what happened in year 2 because that's today. And we compare the prediction based on what person A did in year 1. So that's this blue line. This is the error that we're making, versus using the average predictor in year 1. And that's a much bigger error. So based on the fact that the error for using the past of person A is smaller than the error from pooling person A, it means that person A does not benefit from pooling. So we put him or her in the not pooling group. So this is the sense in which we're doing clusters or classifying people into pooling, not pooling. So we do this for B. Similarly, For B, actually not similarly, because B person, the behavior in the second period was much further from the behavior in the first period than from the pool. So this person would benefit from pooling. And so now you kind of see the gist of it. From person C also would benefit from pooling because that would have resulted in a much smaller error than using their own past for prediction. And for person D, actually they would not benefit from pooling because their own past is a better predictor than pooling for their present behavior. So we now have these two groups, one group of person A and D, one group of B and C. So you see that what this, in this example, perhaps intuitively, what this method does is to single out so-called outliers. So these outliers are people that are away from the mean, whereas the method ends up pooling together individuals that are close to the mean. So this is a quite makes sense, because if I'm very different from everybody else in a good or in a bad way, then my own past behavior is a better predictor than the behavior of the average person. And in fact, visually, what you see here, that the people that we don't pool, A and D, are the people that are further away from the mean, whereas B and C are quite close to the mean, or the pool in this case. Okay, so this, so far so good. This is quite intuitive. You should not pool outliers, people that are very different. But I'm going to present now an example that will challenge your intuition. So you see that from the example, I'm only changing from the previous example what the B does. So now this person B, unlike before, has a different behavior. And otherwise, A, C, and D, the other three people, are behaving exactly the same. What does our method do in this case? How do we classify these people? It's the same for the A, C, and D. So we don't pool A. Now the B person, you see that their error from using their past behavior is much smaller than the error from pooling them. So now we don't pool person B. So if we, at the end of the day, we end up with a very different classification. So now we have two groups where the only person that we pool for whom we use the mean is person C, whereas for the other three individuals, we use their own past behavior. So now you're thinking this is quite challenging for your intuition of these outliers, because B is not an outlier. B is actually quite close to the mean. So what's happening here is that this method is not just singling out outliers, but it's also singling out what we call creatures of habit. We just made this up. In the sense that these are people whose behavior is very consistent over time. So if I keep behaving in a very similar way, I'm not all over the place. What I did in the past is a much better predictor of my future, regardless of where I am in the distribution, whether I'm an average person or whether I'm an outlier. So you can see that this method is data-driven, so you don't have to take a stand. The method does it automatically by looking at your past behavior and identifying whether you are an outlier or a creature of habit. So does this method work? So in order to convince you or the economic profession that this is a contribution, it's a novel contribution, we need to prove that this new method is better than existing ones. So we want to compare it to this tyranny of the majority that we try to fix, which is the pooling everybody. We also want to compare it to this alternative, less common approach, which is only using your past for behavior for everybody. How to evaluate the quality? Two measures. The first is the mean prediction error. So what kind of error do we make? What kind of prediction error do we make on average across people? So if I use my new method, so if you're already using your data and you're using some pooling method, can I improve your prediction? In a sense, would I, on average, give you a smaller error, which would translate perhaps in higher profits, higher revenue? But if you want to go beyond the average, you may care about other features. You may care about the entire distribution of behaviors across your clients, across all the students in the school. And this is increasingly something of interest of economists, social scientists, everybody, because there are important informations that affect your decision beyond just the average behavior. So you may care about the risk or the variance, how wide the behavior is, how wide the behavior ranges. You may care about inequality, whether you may care only about the poorest or the richest and understand their behavior. So we'll consider both measures to see whether our method improves on existing methods. So first of all, I will start from the prediction of the entire distribution, and I will focus only on case one. So what I'm reporting here is the errors that I make by pooling everybody for these A, B, C, D persons. Okay, so you see that we want these errors to be small, so very large errors are bad. And who are we making the mistake for? Intuitively. So if we're pooling everybody, we're using the mean for everybody. We don't make a big mistake for people that are near the mean, so B and C in that case one, but we're making very big mistakes for the two outliers, A and D, because we're pulling them towards an average from which they're very far. So what if instead we only use their past behavior? So these are the green errors. So you see that using the past behavior for everybody as a predictor makes a smaller error for the two outliers for the A and D case, but makes a bigger error for the people that are close to the mean. So this shows you that for people that are close to the mean, B and C, it will be better to pool them. And this is only with 4 people. So imagine when we have a lot of people close to the mean, because if we think of normal distributions, we think that there's a lot of people that are close to the mean and there are few outliers. So the benefits of pooling, of using the mean, would be particularly visible, and we can improve the prediction for people that are indeed close to the mean. However, for the outliers, we can make big mistakes. So what our method does is an intermediate between these two, in a sense. And you see that our method, which is the red bars, is always making the smallest mistake for every person. So for every person is always the smallest, the red. Because for the two outliers, the error that we're making with our method is the same that the error that using only the past behavior would make. Whereas for people that are close to the mean, because our method chooses the pooling, we make the same mistake as if we pooled these two people. So you see that overall, this improves the prediction for everybody. Does this work on average? So finally, if we average this, what is the prediction error? Again, we want this to be small. Can we improve on the two competitors, which is using only the past behavior for everybody, the second line, or pooling everybody? So this is an average error, and the amount doesn't mean anything because we made the numbers up. What matters is which one is smaller. And we see that our method is the smallest in both case 1 and case 2. So we are improving relative to the pooling everybody and relative to using past behavior for everybody. So this shows you that our new method potentially leads to better predictions. So to conclude, I argued in this talk that trying to predict behavior, which is important and we do all the time, and it underlies many important economic and business decisions and policy decisions, may suffer from the tyranny of the majority, in the sense that leveraging big data and pooling and averaging people based on their observable similarities hides important and crucial differences in unobservables. And we think that these are the fundamental differences that drive behavior. So this can lead to bad decisions, in a more benign way to perhaps a loss of revenue. But in a more subtle way, it can lead to unfair decisions by keeping people victim of their circumstances, by perpetuating existing inequalities. And so we propose a method that tries to overcome this tyranny of the majority by not pooling everybody, but deciding, given a group of individuals for whom we have observations on their past behavior, we can decide for each individual whether they would benefit from pooling or not, or whether to single them out. And so this results in better predictions, and it singles out the outliers, as you would imagine. Perhaps less intuitively, it also singles out people that are creatures of habit or people that are consistent in their behavior, and for whom, therefore, their past is very informative. And so this will lead, hopefully, to better and ideally fairer decisions in economic and business and in policy making. That's all I have to say. I want to thank you for your attention, and I wish you an enjoyable rest of the conference.